Okay, so in this quick little video, I'm just going to do a comparison of some C# code compared to the same program but written in Python. So I've got our API open, so we're going to do some requests to our API. So first of all, we'll have a look at the C#. So for the C#, I had to create a project using the command .NET new console, and then it created these files here, the project folder, the binary folder, the objects folder, and the program's C# folder. So you write your code in the program.cs file. Objects are the objects it uses when it's compiling. Binaries where it puts the final compiled program that you can run, and the project file keeps track of everything for the .NET commands. So you can run this of one of two ways. We can go into the bin folder, the debug .NET 6, and then API test. We can actually run it from there. If I just listed that folder just to show you what's in it, let's do that again. You can see there's a few things in there. So we got a runtime configuration, some dynamic linked libraries, and so on. Dependencies. There's a lot going on here. So we can either run it that way, or we can say .NET run. So we've got the program running now, and you can see we've got our API running here. So we'll just list all countries. We listed all the countries. You can see here it's contacted the our API server. That's the JSON that it returned, and of course we formatted it nicely. Press enter. We'll show the continent of a country. So we'll say, just for example, Brazil. The continent that Brazil is part of is South America. Number 3, country's population. We'll just have a look at Australia. What's that? 25 million. Close enough to 25 million. Okay, and lastly we'll quit out of it. Now just to show you, this is a Python program. What do we have in here? Just that one file. That's literally it. That's all we have. So we don't have to worry about creating big projects or compiling and worrying about debug output versus actually release output and all that. There's a whole bunch of stuff. Now obviously a compiled C# program compiles down to the bytecode of the .NET runtime, so ad execution is going to be faster than Python, but you know, in 99% of cases I would really challenge you to be able to see any difference whatsoever when you're running it. We're talking microseconds. So anyway, so if we run this main, I'll say Python run main, and you can see it's exactly the same program. I've written it exactly the same way. So if I say list countries, it lists countries in exactly the same way. Show the continent of country, I think it was Brazil we did. So the continent of Brazil is part of South America. 3, population, we'll go with Australia. Yep, same answer. If we look over here, that's the string we got back. And lastly, we'll just quit the program. So you can see these two programs do exactly the same thing. They're hitting the server, they're doing requests, they are functionally equivalent. So let's go have a quick look at the code. So we'll start off with the C# program. First of all, just scroll down, 1, 2, 3, 4, 5 scrolls, and I get down and it says this code file is 158 lines long. So that's the very first thing I'm going to compare to Python. Python, 1 scroll, 65 lines long. So the C# compared to Python, C# is 2.5 times longer than the equivalent Python code. Now if we have a look at this, we're importing a bunch of stuff. We need to import a threading library. You know, we have to create a namespace, a class. We put our instance variables in here, of which we need a HTTP client variable as well. So we've got a main function that creates an instance of that class and then runs a function to kick it off. Now when we look in here, well, for our function we have to define whether it's private or public. Now because we're using threading, we have to understand that it's an asynchronous program, so we're not just putting in the return type. So we're going to keep a variable here that keeps track of the loop, so we got to make sure we know that that's a variable and this is a string. It's very, very verbose. Every line we have to have a semicolon at the end to indicate it's the end of the line. When we do our while loop, we have to have these brackets here and open and closing curly braces. Again, every line must have these closing semicolons. So we call the console library, which we imported up here somewhere, IO, and then we can write line, we can read line. Okay, we've got our switch case, and to be able to run a function, again, because we're doing API calls, that's an asynchronous event, so we need to do this interesting thing here, which is basically a lambda function inside a task. So there's quite a bit we have to learn about here. We can declare a variable as var rather than having to say the exact data type, so it will figure it out. So we're going to have this task run, we're going to call that, we're going to wait for it to execute, and then we're going to break out of the function. So that one, for instance, if we're running list countries, we come down here, we say it's private function, we don't give a return type of a string or anything, or void or anything like that. We have to say that's asynchronous task that's running when we run this function, list countries. So anyway, we go ahead, we build it. The interesting thing to pay attention here is we have to create a dictionary that we're going to build from our JSON object that we get. So up here we build a URL. We await for the client to run a get string async. So it's going to do a get request. It's going to do it asynchronously. So we're just going to wait for it. Not going to do anything else. And then when we do get it back, we're going to deserialize it. We're going to do the JSON convert, deserialize the object. We're going to have to tell it what we're expecting. We're expecting a dictionary that's got a key that's a string, and its value will be a list, and the type of thing that will be in that list is a country object. Now, to get that country object, we had to know ahead of time what that was, so we had to create a class down here called country that has all the different data that's in that and the type. So whether it's a string, whether it's nullable or not, whether it's a floating point number, we need to make getters and setters for it. We have to do that for 3 different classes here. But going back to our example here, once we know the data type, we create the variable. We have to know exactly how it's all laid out. Then we can do a for each loop. So we get the list, which is, if we call the results, we get that key out of the dictionary, which gives us the list, and we can iterate over that list of things. And then we can finally write out what it is that we're doing. Whew, that's a lot. Now it's going to be the same when we do the other 2 functions. You can see here we've got a string that can be nullable and a string that's not nullable. And we're going through our async, so we're doing all the same things again. We've got to know all our data up front. Because at the end of the day, there's a lot there that we have to know about. Like we have to know about getters and setters and classes. We need to know about asynchronous functions and that we have to do return an asynchronous task. We need to know about these lambda functions, and that's how we run a task. There's quite a lot, and it's 158 lines long. Let's examine the Python version. So there's only 2 imports. OS, the only reason we got that is to be able to clear the screen, and requests is the library that will do the actual get request for us. So here we are, we've got a class in Python, hello, and we just initialize the class. That's what the init is. Kind of like a constructor, but a little bit different. In Csharp, you just put these instance variables in the top of the class. So with Python, we initialize it, and we use a keyword self, which can confuse people when they first come to Python, but basically that steps in for the actual instance of the class that's running. But yeah, that's for another time. It's simple once you get used to it. It's kind of like this if you use this keyword in C#, but you actually have to use it in Python. Okay, so we've got our instance variables, we've got our run. So notice we don't have to create any data types. we just say there's going to be this thing called running and it's set to true. Python figures out that it's a boolean. We don't have to put that in. While running, notice we don't have open and closing braces, curly braces. The only thing we need is this colon and to indent the block so that it knows what is part of that while loop. Very simple I/O. We just call input, give it some string, it'll print that string out to the console, grab whatever you enter and put it into this variable. Again, no data types required. We can just do a match on that input value, match what it is that it actually says. If you've got an underscore for this case, that just means if it didn't match anything else, then run this one. So that would be an invalid selection. Okay, in the case where they did happen to do 4, we're also just going to clear the screen after we finish running. Oh, sorry, if it's not 4. If we're not quitting. In any other case, we also want to clear the screen after we press enter. I can actually shorten that. I don't actually need that there. I can put that into the input. And there we go. I've actually just shortened my program again. I can just do that with one line, and that OS clear is all we needed. Okay, so now let's have a look at the function. When it actually calls list countries, this is way simpler. If I go back here, we've already had to know it's an async task, that it's private. What have I just done there? Yeah, we've had to go through all this stuff. We've had to figure out what our data's like. Let's go over to the Python. We just go return data. We just call the request library that's going to handle our internet requests. We want to get request, and we're just going to give it the string. We don't have to wait for it. We don't have to tell it's an asynchronous. We don't have to do any of that stuff. Just say, do your thing. I got my data. Now I want to take that JSON string, which we just got back, and I want to turn it into a structure. So again, back in the C#, we have to create a dictionary that we know ahead of time how everything's laid out. We need to deserialize it. Over here, we just go grab that JSON and put it into a structure for us. Now I've got this little print statement here just to show you that I can just literally print out country data and it would list out that whole data structure. So if I wasn't sure how to do this, I don't have to know ahead of time. I can just print it out, have a look at the printout, and then I can figure out, this part. What do I have to do? What's in there? Because this will tell me everything. But for now, I'm just going to delete that line. Okay, so our program, it's actually gotten even shorter. It's 63 lines of code. That's really it. So do a GET request, grab the JSON and convert it into a structure that I can use, which is a dictionary. That's why I've got country data results. So for every row in country data results, this is our for each loop. Then we just want to print out the country, and for every row, its name, population's a number, so I'm just going to convert that to a string for our printing. That's it. That's as difficult as it is. If I really wanted to shorten it, I could just go .json on the end of this. Request got get that .json. It would literally be one line of code. I don't do that. I separate it out to make it look simple, but you can literally do the whole GET request in one line of code without having to know about Lambda functions, without having to know about async and return types, and running tasks. One line of code. In my case, 2 just to make it readable. So yeah, that's the big difference. Look at that. One scroll. Go over to our C#. 1, 2, 3, 4, 5 scrolls. I've had to create all these classes. I've had to know, intricately understand the data types, my getters and setters, deserializing into the exact structure. I have to know about what tasks are, how asynchronous works, got all these imports. Just so much going on. So hopefully that gives you an idea of, how powerful Python is. In the words of, what's his name? Eric Raymond. He said Python is the language that does the least to get between me and the problem, which you can see right here. So we don't get caught up in the language, we concentrate on what our actual problem is. So we don't have to care, what the structure is or what the data type is. We just say, hey, stick a true value into this, or go create a whole big data structure and just attach it to this label. We know what we want to do. We want to get that JSON string and convert it into the equivalent dictionaries and lists and, you know, integers and strings. We just don't care how it's done. So C# makes us wrangle with the language. Python lets us just worry about the problem. So yeah, hopefully I've kind of sold Python. That was the idea. You can see these two equivalent programs. One's a hell of a lot easier to write than the other, which also means it's easier to maintain in the long run. It's easy to go in and make changes and not break stuff and think, oh, where in this massive code base did I break it? Why do I have to compile it, worry about release versions, debug versions, you know, remembering all those different files and what they do, and why do I have to have a project? It's just so simple, and there's so many tools around that make it easy. And you can see I can write complex programs like this very API server. Okay, look, I've rambled on enough now. I hope that's given you a good enough explanation of why I tend to reach for Python. I'm not totally bagging C#. It's got its place. It's got lots of nice things actually in the framework. In the .NET, I've noticed lots of really cool little features, code generation. But when you really want to rapidly develop something, you know, nothing's going to beat Python. And that, my friend, is the end.